Good morning to one and all present here. Today we are going to new topic in atomic physics. So atomic physics is a field of physics that studies from atom as an isolated system of electrons and an atomic nucleus. So she see the picture for nuclear protons, neutrons, and then electrons. Next, evaluations in the atomic physics. Evaluations in the atomic physics near had the image produced from Rutherford. So tested was body consisting his massive considered positively charged core. So J.J. Thomson atomic model lacked solid explanation positive and negative entities. So next, modern atomic physics. Recently, power lasers have the dramatically renewed field. Atomic physics lasers have exponentially increased the measurement of atoms characteristics in the wavelength. So you have two in atoms. Atom to the basis in a nucleus and the electrons. So nucleus in the opposite changing the electron, proton, neutrons. So next, atomic structure, electronic configurations. The electronic configurations of atomic dispositions order electron placed among the subcells and atomic cells and subcells. Generally, electron configurations is used above the purpose. So it is also in the anion and action comparisons and the gain of lost electron in the agenda's orbitals. So see the picture in the structure of atoms. So structure of atom is the forward kind of in the atoms in the groups and the nucleus, electrons, neutrons, protons. So orbit. So see is a structure of atom and then atomic physics in applications. Body field atomic physics has applications for the study of conserved matter. So conserved matter in the element of the arrangement of element in the periodic tables, nuclear physics, and then matter, gases, chemical reactions, mechanisms, atmospheric science, in anything, etc. So electrons and protons. Protons and electrons to the basic quantum mechanical particles, but they have completely different properties. So that to the basic quantum mechanical particles and then a completely different properties. So photon is a elementary particles which acts carrier energy, but electron is a subatomic particle across the all the atom. So article will be learn about the definition meaning difference between electron and photons. So electron wavelength. Louis G. Brackley first measured in the wavelength of an electrons. He used the constant of Einstein formula and Planck constant calculating the equation is measure wavelength in this electron wavelength. So you have two formula in lambda is the wavelength, h is the Planck constant, p is the momentum of electrons. The father of atomic physics, Niels Bohr is known as father of atomic physics. She is born in 1885. So the foundation of the modern atomic physics and quantum physics. Next, the structure conclusion. Structure of the atomic atom is the best way describing. So best way describing properties of atoms and helps understanding different behavior characteristics in the future of the atoms. So next we see the next topic in isomerism in organic chemistry. So isomerism organic chemistry is a phenomenon by two or more organic compound having the same molecular formula but different properties in the utmost along carbon space structural isomerism and then structure isomerism stereo isomerism. So first classifications of isomerism. So there are three types. So two types: structural, stereomerism. So structural isomerism is type of classified into six types: chain isomerism, positional isomerism, functional isomerism, ring chain isomerism, metamerism isomerism, and then tautomerism isomerism. So first chain isomerism, the same molecular formula but represent two or more compounds. So it differs natural carbon chain. Example C4H10 between has two isomerism butane namely and two methyl propylene. Next, positional isomerism. The same molecular formula represent two or more components. So it differs the positions of the same functional group, but difference functional group. So example, butane has two isomers, namely but one one butane, two butane. Next, functional isomerism. The same molecular formula but represent two or more components. A different nature of the functional group. Example, C3H3O2. The isomerism namely propanonic acid methyl ethanoate. So next, fourth one, metamerism isomerism. So metamerism isomerism is the same molecular formula and then the presence of two more components. It differs as the two naturally alkali metals in the same functional group. Next example, diethyl ether and then methyl propyl ether metameryl isomerisms. Next, ring chain isomerism. The same molecular formula represent two or more components. Is defined as the mode linkage carbon of the atoms. This isomers have the either ether open chain and then closed chain. Next, tautomerism isomerism. So tautomerism isomerism in some molecular formula represent two or more components and then exits dynamic equilibrium with other can be present in many such of nitro from acid from catho from an anolic form, etc. Next is stereoisomerism. The isomerism different spatial arrangement of atoms groups. It is two types, geometrical and optical isomerism. So conclusion has been mentioned about the isomerism. You come to do it in the compound formula and then molecular can be represent different structure isomerism. Each other phenomenon has been named in the isomerisms. Thank you.